So for today, this is your help video for the Unit 3 sample work. And remember, sample work is located in Schoology, and it is your unit review before you take the test. All right, write a rule that describes the number sequence, 5, 7, 9, 11. So when we write a rule, we basically have to tell people how they can recreate this number sequence. So we got to tell them what to start with. And then we got to tell them what to do each time to get to the next number. Start with and what to do. So in this case, we have to start with 5. So you're going to tell them start with 5. And then to get from 5 to 7, we added 2. To get from 7 to 9, we added 2. To get from 9 to 11, we add 2. So you have to start with 5 and you have to add 2 each time. So when we tell them what to do, you can say start with 5 and then get rid of this. Then add 2 each time. That way anybody could recreate this sequence. They would know what to start with, they would know what to add, so they could get the exact same thing. Greg planted dahlias in his garden. Dahlias have bulbs that divide and reproduce underground. This year, Greg's garden produced 6, or the first year, sorry. The second year, they produced 13 bulbs. The third year, it produced 20 bulbs. If this pattern continues, how many bulbs would Greg expect in the 10th year? Okay, so first let's figure out what's happening. To go from 6 to 13, we're adding 7. To go from 13 to 20, we're adding 7. But if you look at that and you don't automatically see the pattern, you can always find the common difference. Let me open up my calculator. To find the common difference, you start with the biggest number and subtract. So you could come to your calculator and you could go, okay, 20 minus 13, that's 7. And then you could try the next one, 13 minus 6, that's also 7. So that's how you can figure out that common difference. Some of you might be able to look at it and just say, oh, I know I'm adding every time. And for some of you, you may have to go and subtract to find the common difference. It's okay no matter which way you do it. Oops, minus 6. Okay, so we want to know what happens in the 10th year. So we have the first, second, and third year. You can just continue the pattern if you want to. 4th, 5th, 6th, 7th, 8th, 9th, 10th. So if you wanted to do this, you would just keep adding 7 every time. 20 plus 7 would be 27. 27 plus 7 would be 34. 34 plus 7 would be 41. Then add 7, you get 48. Add 7, you get 55. Add 7, you get 62. Add 7, you get 69. So there would be 16, in our situation, there would be 69 in the 10th year. I think that's the easiest way to do it. You can write a rule. You can say y equals x plus 7. Wait, that doesn't work. Hang on, let me think about that rule for a second. Okay, so I had to think about this for a minute. If you want to write the rule, you would say whatever your first term is, plus, and then n minus 1 or x minus 1, and then times your common difference, which is 7. But I wouldn't suggest writing the rule since we didn't really teach you that, but you could plug it in here. And you could say 10 minus 1 is 9, 9 times 7 is 63, plus 6 is 69. So you could get it by writing the rule, but I would just go ahead and add it up 10 times. All right, Betty has a new remote control car. The graph shows the speed of the car in a trial run. When did Betty bring the remote control car to a complete stop? So if you're at a complete stop, your speed has to be 0, right? So we're going to look over here, and the only time the speed is at 0 is right here at 5 seconds. So if you're at a complete stop, your speed has to be 0. So just look for when that happens on the graph and tell the time. Which graph represents a person's distance from their house if they walk from their house to the end of the street and back 2 times? Well, this to the end of the street and back 2 times is a pretty good giveaway. You're going to start close to the house, you're going to walk away, then you're going to walk back to the house, then you're going to walk away, and you're going to walk back to the house. Nothing else happens 2 times, right? Like this is, you can kind of just use a little bit of common sense to figure out that one. All right, which table contains input, output values for the function? So I did kind of rearrange these when I put them up there, so be careful when you pick your answer. But there's a couple of things going on here. The first thing, you could plug in every x value and see which one works. Or since we've already talked about slope-intercept form, where m is the slope and b is the y-intercept, you could do a process of elimination pretty quickly by looking at that y-intercept. If your y-intercept is 13, anytime it crosses the y-axis, you know that the x value has to be 0 because you didn't go this way x, you didn't go this way x, your x is 0. So our y-intercept would be at 0, 13. So if we look for everywhere that x is 0, here it says 0, 9. I know that's not it. 0, 13, that's a possibility. 0, 13, that's a possibility. 0, 9, that is the wrong y-intercept. So we've at least narrowed it down to 2 options just by looking at that y-intercept. Now I am going to go ahead and plug in to see which one works. So I'm going to plug in a -3 for x, and I'm going to see what it gives me for y. So I'm going to do it right down here. I'm going to do -4, and then for x, instead of writing x, I'm going to substitute in a -3. -4 times -3 is -12 plus 13. That is a +1. And that is what y was supposed to equal. It was supposed to equal 1. Here it says that you plug in a -3 and you get a 25. That's not true. We just said that you get a 1. So this one is my answer. And you could also, well, I don't have time to really go over this, so I'll skip it for now. Given f of x equals 5 plus 6x, find f of -2. So in other words, see how it's originally written as f of x? If you want to find f of -2, it's just telling you that wherever you see x, you replace it with a -2. And anytime we substitute things in, we always put them in parentheses. So here I see an x, but instead of writing that x, I'm going to put a -2 in parentheses. I'll change that color there so we see where that comes from. And then we're just going to calculate it. You can do this part in your brain or your calculator. We're doing 5 plus 6 times -2. And remember, order of operations does say that you have to multiply before you can add, or you can just type it on the calculator and the calculator will do the order of operations for you. All right, so we get a -7. If you did 6 times -2, that's -12 plus 5, you would have gotten the same thing. So f of -2 equals -7. That would be your answer. What is the slope of the linear function graph below? So remember, slope is your rate of change, and when we look at a graph, we usually think of it as rise over run. So let's start from our bottom point. Oh, and I like to always figure out if it's positive or negative first. This is going uphill, so I know that the slope has to be positive. All right, so I'm going to start at the bottom, and I'm going to rise up and run over. Now, here's a really common mistake. A lot of people look at that and say, okay, I'm going up to, I'm going to do this in red because this is not right. I'm rising up 2 and over 1, so my slope must be 2. That's not correct because if we look here at how the axis is labeled, to go from 8 to 12, we're actually going up 4 numbers. So you got to be really careful on how it's labeled. So we're actually rising up 4, and then we're running over, well, it's not labeled, but it goes 4 and then 8. So we're going by 2 each time. So 0, 2, 4, 6, 8, 10. So it goes up 4 and then it goes over 2. Oh, this actually ends up reducing to the same. In my situation, it ended up being the same. But in a lot of situations, it wouldn't, depending on how the graph is labeled. So make sure when you do your rise over run, you look at the axis and see how it's labeled. All right, the graph below shows the amount of water in the tub. What does the slope represent in context? So let me scroll down a little bit. Let's see, we start with 13 gallons, and then over the course of, what is this, about, wait, it goes about 18 minutes, it gets all the way in. Well, it gets down to like 2 gallons. So the number of gallons is decreasing over time. And now if we go to find the actual slope, first of all, we know the slope has to be negative because it's going downhill. It's decreasing. So slope has to be negative. So we can look down here and we can go ahead and cross out this one because it says the slope is positive and it's not positive. All right, and then we can find the actual slope by doing rise over run. I'm just going to go from this point to the next point. And let me finish labeling these. 0, 2, 4, 6, 8, 10. Okay, so I'm going to rise up and run over, but it's not 1 over 1. You have to look at how it's labeled. So here we're rising up from 4 to 6. So we're actually rising up 2. And then we're running over from 15 to 12. So we're actually running over 3 smaller, which is why it's a negative. So my slope here is a negative 2/3. So we know it's not a negative 1. So it's one of these two options. So let's see what it says. The slope is negative 2/3. This means that every 3 minutes, 2 gallons of water is drained from the tub. This one says the slope is every 2/3, which means every 2 minutes, 3 gallons of water is drained from the tub. So we just got to go back and think about what this means. The rise here was the water. So this was 2 gallons, and then the run was time. So it's draining 2 gallons every 3 minutes. So it would be this one. Which triangle should be used to determine the slope of the line graph below? Okay, so we talked about this. The slope of a line is always the same. It has the same steepness all the way through if it's a straight line. So it does not matter what you use to find the slope. No matter what, it will reduce to the same answer. So we don't have to use the red triangle because it's smaller. Neither triangle because you need a table of values. You don't have to have a table of values. You can do the rise over run. The blue triangle because it's positive. No, they're both going to be positive. They're going to be the same. So both triangles, because the slope of the line is constant. If you found the red one, it would be up 2 over 1. If you found the blue one, it would be up 4 over 2, which also reduces to 2 over 1. It does not matter which one you use because the slope will be the same. All right, which graph represents the linear function? So we have a graph in slope-intercept form. Remember the number with x is the slope, and the number at the end is the y-intercept. I usually like to look at a couple things. First of all, I look at the slope to tell whether it's positive or negative. 1/2 is a positive number, so I know my line has to go uphill. This one's going uphill, this one's going uphill, this one's going uphill, this one is going downhill. So I'm going to go ahead and cross that one out. Then I like to look at my y-intercept. This tells me where it crosses the y-axis. So I'm going to look at each of my y-axes and I'm going to see which ones cross at negative 1.5. Okay, so here, this crosses at negative 1.5. That one's okay. Here it crosses at 3. That's not okay. Here it crosses at 5. That's not okay. And that one's already a goner. So this one has to be my answer because it has a positive slope and it crosses the y-intercept at negative 1.5. Oh, that's it. All right. Good luck on this Schoology assignment and make sure that you're using it as a test review. If you have any questions or concerns before the test, make sure you come to live help time.